Welcome and hi, my name is Muhammad Izmin bin Hamidi. My matrix number 08DKA21F2064, and this my group members MAISARAH binti ZAINAL, Sharifah Baitie binti SYED HAMIZON, and NURUL UMAIRAH binti RAFI. Differentiation is a technique used to calculate the gradient, centering point, maximum and minimum point of particular function. For example, we use differentiation to calculate cost, strength, amount of material used in building, profit and also loss. Differentiation are made in many engineering and science problems, especially when modeling the behavior of moving objects. Next is increasing and decreasing function. The derivative of a function may be used to determine whether the function increasing or decreasing of any interval in its domain. If f prime x more than 0 at each point in an interval, the function is said to be increasing. If f prime x less than 0 at each point in interval, then the function is said to be decreasing. Because the derivative is 0 or does not exist only at critical point of the function, it must be positive or negative at all other points where the function exists.
A stationary point of function. In mathematics, particularly in calculus, a stationary point of differentiable function of one variable is a point on the graph of the function where the function derivative is 0. Informally, it is a point where the function stops increasing and decreasing. Stationary points are easy to visualize on the graph of function of one variable. They correspond to the points on the graph where the tangent is horizontal, which is parallel to x-axis.
For function of two variables, they correspond to the point on the graph where the tangent plane is parallel to the xy axis. So, to determine the stationary point is a maximum point or minimum point or a point of inflection, we must apply the second order derivative.
Okay, at all stationary points, the gradient is the same, but it is necessary to know whether you have found a maximum point, minimum point, or point of inflection. Therefore, the gradient at either side of the stationary point need to be looked at the second derivative.
Moreover, I'm going to explaining for maximum point and minimum point. So at maximum point, the gradient is positive just before the maximum. It is 0 at maximum and it is negative just after the maximum. So at minimum point, the gradient is negative, 0 then positive. Finally, at points of inflection, the gradient can be positive 0 or negative 0.
Okay, so next is the example equation for stationary point. So the equation is find the stationary point on the curve y is equal to x squared plus 10x plus 30 and determine what type the stationary point is. So here we know that the equation is y is equal to x squared plus 10x plus 30. So the first thing we need to do here is we need to differentiate the equation, right? Okay, so therefore dy over dx is equal to 2x plus 10. So stationary point dy over dx is equal to 0, right? So 2x plus 10 is equal to 0. So 2x is equal to negative 10. So x will be negative 10 over 2. So x will be negative 5. So after that we get x is equal to negative 5, right? So here after that we need to find the value of y. Okay, so then we need to find the value of y, right? So take the equation back, then put the value of x in the equation. So y is equal to negative 5 square plus 10 times negative 5 plus 30. So here the value of y is 5. So we get the value of x is negative 5, then the value of y is 5. Therefore, we know that the stationary point is negative 5, 5. Okay, so next we need to find and we need to determine what type the stationary point is, right? So here we need to do the second order derivative. So dy over dx is equal to 2x plus 10. So d square y over dx square is equal to 2. So we know that 2 is more than 0, right? So that's mean this stationary point is a minimum point. Thank you.
Okay, next, I'm going to explaining one of the example question for rate of change. So the question was, this diagram are showing a metal cube which is expanding uniformly as it is heated at time represent T. The length of each edge of the cube is X centimeters and the volume of the cube is V centimeter cube. So for answering question A, so the question A first was asking show that dv by dx equal to 3x squared. In order to answering this question, first of all, as we see in the diagram, the volume V is equal to x times x times x. So in other words, it will be x cubed. And it's follow if we differentiate this with respect to x, dv by dx, and usual it's going to be 3x squared. So for answering question B and C, the question states that given that the volume V centimeter cube increases at a constant rate of 0.048 centimeter cube per second. So for question B, it was asked find dx by dt when x equals to 8. So in other words, find the rate of change of the length x when x is 8. So what we should to do first is put down dx and dt. How we are going to get dx by dt? Well, this is where we connect rates of change. So I just write dx and then I write dt. Underneath dx, I put dv, and then on top of dv, I put dx. After that, cancel both dv's, leaving dx and dt. And this is called connected rate of change. After that, I write 1 by 3x squared, where I got from the question A, then multiply with a 0.048 that was given in the question, and the answer will be 0.016 over x squared. And then we already answering part of the question, which is find dx by dt. Right now, we are going to answering other half of the question, where it was mentioning when x equals to 8. We can figure out dx by dt is going to be equal 0.016 divided by 8 squared, and if we calculate it, it will be 0.0025 centimeter per second. So next, for question C, it was asked find the rate of increases of the total surface area of the cube in centimeters square per second when x equals to 8. So first of all, what we should do is we have to write down the formula, which is dA by dt equals to dA by dx and dx by dt. Since we already find dx over dt, which is the answer was 0.016, and then we have to find dA. The total surface of the area is A alphabet equals to 6 because of the surface of the cube is 6. So dA by dx, if we differentiate A with respect to x, is going to be 12x. Next, we have to substitute value in dA by dt must be equal to dA by dx, which is 12x, and now it's multiplied with dx by dt. In general, for any value of x was 0.016 divided x squared and put in a bracket, and if you calculate it, the answer will be 0.192 by x. The question also mentioning find when x equals to 8. So for answering this question, we have to write down dA by dt equals to 0.192 divide 8. The answer will be 0.024 centimeters square per second.
So in the conclusion, with the help from the previous slide, we can acknowledge that the differentiation is used in almost in everything. With the use of differentiation, equipment like odometer, speedometer can be improved. So, a function is used to be increasing when its gradient is positive and decreasing when the gradient is negative. Next is a stationary point occurs on the curve of a function. when the gradient at the point is 0. Stationary point can be minimum point, maximum point, or point of inflection. Okay, thank you.